Hi everyone, and welcome to this video where we're going to be covering ions and ionic bonding. So before you've come into this video, hopefully you've got a bit of an understanding of the structure of the atom and a little bit of an understanding about how covalent bonds form. We're going to have a bit of a focus in this one on the differences in how the bonds form in an ionic compound compared to a covalent compound. Before in future we'll be looking at how that actually affects their properties. So the first thing when we're considering ionic bonding is really thinking about the word ion and what an ion actually is. So one of the first rules we learn when we're learning about atoms is that the number of protons and the number of electrons in an atom are always equal, which results in an atom having no charge. So often your chemistry teacher will ask you a question about how something containing positive and negative particles, or protons and electrons, can have no charge. You're expected to know that there are equal numbers of them. Now, the easiest way to think of an ion is that it's not something completely new. It really isn't. It's basically the same as an atom. The only difference being that this rule is broken. The number of protons and electrons are no longer equal. That means we can't call it an atom anymore. We need to give it a new name, and that name is an ion. But realistically, they are still made up of protons, neutrons, and electrons. They still have a nucleus. The electrons are still orbiting around the outside of that nucleus. Nothing really is different other than this one rule is broken. What we need to understand is that ions are going to be formed when an atom either gains or loses electrons. And just like with covalent bonds, the purpose of doing that, the reason why an atom would do that, is in order to achieve a full outer shell. Remember that a full outer shell in chemistry is going to represent stability, and that's ultimately what every atom is looking to be able to do. So when learning about covalent bonds, you've probably learned the rule of thumb that covalent bonds only form between non-metal atoms, and that is true about 99% of the time. There are a few exceptions to it, but basically it's the easiest way for us to kind of summarize it. We can do a similar thing with ions and ionic bonding, which is that ions are usually going to form when a metal and a non-metal react together to make a compound. What we find when we look at these examples, and we'll look at a few in a moment, is that it's not really possible for the metals to achieve a full outer shell by sharing. They're too far away from being a full outer shell in order to be able to share. And so what happens instead is that atoms will either gain electrons or lose electrons in order to fill up or empty that outer shell. And that changing in the number of electrons is going to create either a positive charge overall or a negative charge overall, and that's what we call an ion. So just like we did when we started covalent bonding, the first thing that would be best for us to do is to have a think about the structure of the atom and to remind ourselves about something called a target diagram. If we start here with the element fluorine, it has 9 protons and 9 electrons. With that number of electrons, 9, we can then write an electron arrangement. 2 electrons will go into the first shell, 7 electrons into the second shell, giving us an electron arrangement of 2,7. We can draw that. We start off with our symbol, F for fluorine. We draw 2 circles because there are 2 numbers in the electron arrangement. We put our first 2 electrons onto the first circle as long as they're opposite one another. Our 7 then go on where we go around the outside of the circle once. That gives us our 4 electrons. There are 3 remaining, so we go back to the top to pair up, to the right hand side, and then to the bottom. This is our electron arrangement for fluorine, our target diagram for fluorine, and what we would be looking at doing now is altering that last number, that number 7, and how that number would change in order to achieve that full outer shell. So let's have a little bit of a think about how we could take that target diagram for fluorine and change that into an ion. So the first thing we have to understand is that our non-metal atoms are normally going to gain electrons. Okay, so our non-metals will normally gain electrons in order to fill their outer shell. When they do that, what we end up with is an imbalance between the number of protons and electrons, where we have more electrons than protons, because the number of protons never changes when we're looking at ions, and that's what leads to a negative ion. So let's look at this example of fluorine. With 7 electrons in its outer shell, it's only 1 electron away from being a full outer shell. So what if we were able to add 1 electron into that outer shell? And that's exactly what happens. You can see here I've coloured the extra electron red. Just to be clear, all the electrons are exactly the same. There would be no way to tell which one it was. This is really just to try and help us kind of understand and to be able to visualise what's going on. But you can see here that what we've done is we've filled up that outer shell. That now becomes stable. Okay, now because our number of protons has stayed the same, being 9, but our number of electrons has changed, we now have a charge. Okay, and that charge is what makes it an ion. Now with negative ions, you'll notice that the name of the ion also changes. Just like when we learned how to name compounds, the negative ions are the ones where the ending of the name of the element is going to change to IDE. So with 9 protons but 10 electrons, their fluorine becomes a fluoride ion. So our 9 protons that were originally here are still present in the ion. The 10 electrons that are here means we have 1 more electron than we have proton, and therefore we have this negative charge. Now you can show that. Usually what we would do is pop that into brackets and we put a charge up at the right hand side here to show that that is the charge on the ion. So let's think about what's different when it's a metal. Well, when we take our example here, which is sodium with its 11 electrons and its electron arrangement of 2, 8, 1, we can see that that outer electron, that single outer electron, this one up here, is the only electron in this shell. That means that it is 7 electrons away from being a full outer shell, but it's only 1 electron away from being an empty outer shell. And that's an important idea, because if we were able to empty this third shell, all of a sudden, without that third shell being there or being occupied, our second shell becomes the outer shell, and that second shell is already full. Now remember, the goal here is to achieve a full outer shell. So the quickest and easiest way for our sodium to achieve that is not to gain 7 electrons to fill up its outer shell, but rather to lose 1 electron in order to empty that, creating the inner shell now being an outer shell, which is already full. So let's have a look at how that works. Our sodium, okay, is going to lose its single outer electron like this, giving us now only 2 electron shells rather than the 3 that we started with. But because we have 11 protons, just like we started with, but we now have 10 electrons, we now have 1 more proton than electron, or 1 fewer electron than proton. And when that happens, what we create is called a positive ion. And we can show that at the top right hand side here with our positive symbol. Now the only difference with other examples might be that you lose maybe 1 or 2 or 3 electrons. And so what would happen is if you were to lose 2 electrons, your charge would become 2 plus rather than plus. If you were to gain 2 electrons, it would become 2 negative rather than just negative. So the number of electrons that's gained or lost is shown when we have our charge up the top right hand corner here. The examples I've shown you so far are fluorine example and our sodium example, both change by just 1 electron, which results in our single charge. Now in reality, these two things don't happen without one another being present. Sodium can't just throw an electron away into the ether, and chlorine can't just nip down to B and Q and buy itself an electron. You need to have a partnership going on. So here what we've got is a slight variation in the example. We've got chlorine rather than fluorine, but the same basic theory applies. We've got sodium with its 1 outer electron, chlorine with its 7 outer electrons. And what will happen is our sodium will take its outer electron, it will lose it by giving it to the chlorine. So in covalent, we looked at the idea of sharing electrons. Well, in ionic, we look at the idea of stealing or giving electrons from one atom to another. Our sodium achieves its full outer shell with 8 electrons. Our chlorine achieves its full outer shell with 8 electrons. Our sodium atom and our chlorine atom have become a sodium ion and a chloride ion. So one cannot happen without the other one being present. And when we look at the numbers of protons and electrons, what we see is that in the left-hand side, our atoms, the number of protons and electrons are always equal, whereas on the right-hand side for our ions, that imbalance is now present, which is why we have ions rather than atoms. When we have extra protons, when we have extra electrons, we have negative ions, and when we have fewer electrons, we have positive ions. And that's something that you really need to be careful with. When you add electrons in, we think of adding in, we often think of positive, but what we're adding is a negative electron. So adding more in makes it negative, taking away will make it positive. So how does this work in terms of bonding? Well, actually ionic bonding is far easier for us to visualize and to understand than covalent bonding, because once that transfer of electron has happened, once we've created our positive and our negative ions, what we create is two opposite charges. And in chemistry, one of the most fundamental rules that we have, one of the most important rules that we have, is that opposite charges attract one another. It's the reason for a lot of chemistry happening. It's the reason why a lot of chemical reactions take place. Is all to do with attraction, and opposite charges attract each other. So as soon as your sodium loses its electron, becoming a sodium ion, your chlorine picks up an electron, becoming chloride. Those two ions will then attract each other. This attraction that they have for one another is what's known as an ionic bond. So the definition for an ionic bond is the electrostatic. Now we don't need to necessarily have that word, don't worry too much. An ionic bond is the attraction between positive ions and negative ions. Okay? Now you'll see here an analogy that's often used in chemistry, which is that these are like magnets. And I just want to be clear about this. They are like magnets. They are not magnetic. Okay, this is not about two opposite magnets attracting each other, but it does result in exactly the same type of force. A magnetic attraction very much resembles an ionic attraction, but just to be clear, if you're writing an answer, we're not going to be talking about magnets, but we can use the idea of magnets as a way to kind of visualize what's happening. Think about if you've ever used one of the magnets that we have in the science department, where one half of the magnet is blue, the other half of the magnet is red. If you were to then take a different magnet, the blue on one will attract the red on the other, which gives us this idea of opposites attracting. So let's recap this and bring it all back together. What do we need to know about ions and ionic bonding? The first thing we need to understand is that ions form when an atom gains or loses electrons, creating an overall charge. Remember, in an atom, the number of protons and electrons are the same and there is no charge overall. In an ion, that rule is broken and we have a charge. Metal atoms will normally lose electrons, and in doing so will become positive ions. Non-metals will normally gain electrons, and in doing so will become negative ions. And lastly, when we have two oppositely charged ions, positive and negative, they will attract each other, and this attraction is what we call an ionic bond. Okay, I hope you found this video useful. If you have any difficulties at all or any problems, feel free to reach out to your chemistry teacher, and I hope you have a great day. Thank you.